stuck on this problem for hours. I don't know what to do. Maybe just a short little break. What?
Math support! Having trouble with your math? Call math support.
Japan is an island by the sea filled with volcanoes, and it's beautiful. In the year negative a billion, Japan might not have been here. In the year negative 40,000, it was here, and you could walk to it, and some people walked to it. Then it got warmer, some icebergs melted, it became an island, and now there's lots of trees, because it's warmer. So now there's people on the island.
I should call math support. Hello, math support?
Hello, this is Math Support. How may I help you today?
Hey, yeah, I'm having a problem on this math, this math problem. Kind of stuck on it. You know, the one about Ruth riding her bicycle on this weird trail or something, something really boring.
Yes, I know the one you speak of. I have it right here. How far have you got?
Okay, well, I have A down already, I'm trying to find the acceleration at t equals 1.4, which basically, since 1.2 and 1.6 are on equal sides of 1.4, you'd plug that into like an average value theorem and get vaguely, negative 2.25 miles per hour squared.
Good work. You bring honor to your family. For next question, I bring you to Special Agent. Its name, Ruth. Ruth! Call on 911! Ruth!
What? Yes, Ruth here. I explained part B. Da?
And as for the Riemann sum on part B, you have to do 0 to 2.4 v of t dt is approximately 0.8 times 11.8 plus 0.8 times 17.2 plus 0.8 times 16.8, which is approximately 36.4 miles, which the interpretation of that is me, Ruth, has traveled approximately 36 miles from 0 hours to 2.4 hours.
And now, back to Mr. Yelve in math support. Thank you for calling.
Many thanks, Ruth. So, for part C, we're given the time interval of 0 to 2.4 hours for the time t. We're given Ruth's velocity, which is modeled by the function g, which is g of t equals 24t plus 5 sine of 6t over t plus 0.7. And we're trying to find the average velocity for Ruth during that time interval said previously of 0 and 2.4. So using f average, or commonly known as fave, we can calculate the velocity at the average of 2.4 and 0 by plugging it into the equation. We know that the first part is 1 over b minus a. In this case, the a value would be 0, so it would just be 1 over a, or 1 over 2.4. The integral would be from a to b, or 0 to 2.4. And we know the function, which I said previously, 24t plus 5 sine of 6t over t plus 0.7. When we plug in all of our values, we can get the value of 14.064 miles per hour for the average between the interval of 0 and 2.4 hours.
Okay, those two sound good, but now what about D?
As for the D, I send you to intern.
Hello, it's me, the intern. Okay, so for part D, in order to see if Ruth's speed is increasing or decreasing at time equals 1.3 seconds, first what you're going to want to do is plug in 1.3 into the function of g. When you plug in time 1.3 into the function of g, you're going to want to see if your answer is greater than 0, and then what you're going to want to do is take the derivative of the function of g, and then do the same thing, plug in 1.3 seconds, and if both of your answers are the same sign and above 0, then you could say that Ruth's speed is increasing at time equals 1.3 seconds, since velocity and acceleration have the same sign at this time. Okay, thank you for calling. Have a nice day. and then once you do that, you want to see if no. Okay, like redo it.
Living the dream.
Go! How you doing?
Hard at work.
Hard at work or hardly working there?
Sorry, reviewing one more time. Okay,
And those are the one you speak of. Which part are you stuck on?
I know the one you